Okay, so we are live. Let me share the screen. Okay, so what today's Leetcode POTD is widest vertical area between 2 points. So what's our problem statement is? So we have been given an vector of points and which we need to plot in our 2D graph. Like we can see, we plotted 8 comma 7 and 9 comma 9, 7 comma 4 and 8 comma 7. And so we need to find the widest horizontal distance between these points. For example, here we can see the distance between 7,4 and 8,7 is 1 units, and distance between 8,7 and 9,7 is also equal to 1 units, and distance between 9,7 and 9,9 is 0 units. So we need to check the maximum units that are there, which is the 1. And if we see another example where we have been given these points and we plot them in the graph, and as you can see that the maximum gap between them is from 5,3 till 8,8, which is equal to 3 units. So if we see our questions clearly, then we can see that we only need to consider our x values. We need not we don't have any need for our y values. We can proceed without them. So let me write this code. First of all, we'll be using one vector array, and we'll be pushing our x values to our array, and then we can simply sort our array. And then we will traverse and check the maximum gap which is there between these points. And after that we can just simply return our answer variable. Okay, so let's try running it. Okay, let's try submitting it. Okay, so as you can see guys, it got submitted. So this was all for our Leetcode POTD. So now over to you, Sangam.
See, guys, the question that we have been asked today's GFG PODT is that there is an array that is given to us, and in that array there are elements that are given to us. They have some kind of priorities associated with them. So, as we live in a society, we know that VIP people are important, VVIP are more important than them, and ultra VIP are like the super top of the class in terms of population. So that is a similar kind of atrocity is what we have been given here, that in our array 1 0 and 2 is the priorities of any given element. 1 means that it is greater than zeros and 2 means it is greater than 1. Now we have to allocate candies to these members of our array, and the thing is that the person with the higher priority should get more candies than the person with the lower priorities if that person is adjacent to it. Now what does this means? So where is our excel? Yeah. So what does this means? So let's say this is our current example that we have been given. Okay, now we are at the first instance. We are going to observe first of all the previous element, that is anything that is would be available there, and the element that is next to it. So we are just going are concerned with respect to the adjacent elements 2 1, and we are going to see if these elements are smaller than or greater than this. Now if they are smaller, then the number of candies that this one get should be more than these adjacent elements. Okay, so in this case the candy that one should get would be more, so we can just allocate it at 2. Okay, let's just, for the sake of explanation, we are just going to allocate it to 2. Now we are simply going to move on to our second element. So for this element we are simply again going to consider the two corresponding adjacent elements. So we considered 1 and 2, and then we are going to figure out that one that zero's priority, as you can see, it is smaller than 1. Okay, and it is also smaller than 2, so its candy should be less than its adjacent more priority elements. So let's just allocate the candy to be as 1 to this element. Okay, and after that let's just move on. So after we move on, now we reach at element 2. Now we have again to check the corresponding elements with respect to it. And as you can see that 2 has a greater priority than 0, and there are no other element that is present at the right side of it. So we are simply going to consider the left side element. And as we can see that it is more important, so it had to be allocated candies that are more than the one that had been allocated to 0, which is 1 in this case. So we can simply increase its candy collection to 2. So this way what we have done is, the given array that had been provided to us, we have assessed the elements on the basis of priority, and the one with the greater priority corresponding to its relative neighbor should get more candies. That is the simple logic that we have assigned in this case. So there are the thing that we have to consider while solving this problem is that at any particular index we just have to look at the person that is behind it and the person that is ahead of it, and just have to observe the priorities regarding them. If they are smaller, if this element is smaller than this one, that is our middle element is greater, then the candies that should be allocated to our middle element should be greater than the candies that had been allocated to this element. And and if our current element is smaller than the element that is present here, then the candies that to be allocated to our current element should be smaller than the candies that had been allocated to the next element. Now the question arises, like, how we are actually going to solve this problem. So let's just make it as simple as possible for us to solve this problem. Okay, what we are going to do is, we are going to consider an answer array, and in that answer array we are simply going to push all values as 1. The size of the answer array to be is would be equal to the size of the array that we have been given as per the question requirement. So as you can see, in this case the size of the array is 3. That is why for the answer array in which we have assigned value as 1, its size is also 3. And then we are going to do two passes. First pass will be from left to right, and the other pass would be from right to left. So let's just consider the example of 102 that we have been given. Okay, and the pass that we are going to do now is from left to right. And in that pass, the thing that we have to see is that if the element that is present at left, okay, if it is smaller than the element that is present to its right, then this element's candies should be greater than the candies that had been allocated to the previous one. So what does this mean? Let's just say our initial element is 0. Okay, and the element that is next to it is 1. So as we can see, the priority of 1 is greater than 0. So the number of candies that this element should get should be greater than the number of candies that 0 had. So in this case, 0 had 1 candy. So this 1 should have more candies. So we are simply going to increase its candy size by 1. So its ultimate size would becomes to be 2. That is what we are doing in our left to right scenario. We are just assessing the elements from left to right and checking if the element present at right had higher priority than the element present at left. If it is the case, simply allocate the candy to the right element just one larger than the candies that had been allocated to our previous element. That is what we are doing in this case. So simply we are going to move from left to right and we are going to consider this element. We are simply going to ignore the first element in this iteration, and I will let you know later that why we are doing this thing. So let's just consider this one. Okay, so we are at index 1, here it is index 0, and here it is index 2. So we are at index 1 and we are checking that if the element that is present at index 1 is greater than the element that is present at index 0. So as we can see, it is not the case, so we are simply going to move forward. Okay, so now after we have done this thing or done this iteration, we are now going to move at our index 2. And remember guys, initially we have allocated 1 1 and 1 candy to each of these elements. Okay, so now we are moving forward. Now we are checking that the element that is present at index 2, which is 2, is greater than the element that is present at index 1, which is 0. So as we can see, 2 is greater than 0, that is 2 had higher priority than 0. Then do what? In this case, do what guys? As we have already discussed here, simply allocate one more candy to the element which have greater priority than the one before. So as you can see, for 0 we have allocated one candy. So in this case, simply give one more candy in 2 section. So the candies that would be allocated to will become now 2. Okay, and after that we can't move anywhere forward, so we are simply going to and this code of left to right here. So this is our first part of the problem that we have done. And in this problem, what we have done is we have assessed the elements that are greater than the current one and simply had given them more candies according to their order. Okay, now comes the second part. In this part, what we are doing, we are going to access elements now from right to left, and in this order simply applying the same logic here, that if the element present at right had like, oh no, it is a little misunderstanding that I had done in this case. We are now moving from right to left. The logic would be similar. Now, if the element present at left had higher priority than the element present at right, then simply allocate one more candy to the element present at left. Okay, so now let's just apply this logic to our current matrix or current array. This is the one, this is our array, and this is what we had got after doing the iteration of right to left. So now we are moving from left to right. We will start from here, simply ignoring this element, because if we start from 0, with whom we are actually going to compare? Huh? To this element, there is no one available there. So that is the reason why we are comparing it with the next one index. Okay, so now we are going to compare one, that is, let's just mark it as index wise, it would be more easy to understand. So 0 1 and 2. Now we are going to check the element that is present at index 1 is, it had higher priority than the element present at index 2, because we are moving from left to right, so we are moving in this direction. Okay, so 1 had greater or not? So the element that is present at 1 is 0 and the one at present as 2 is 2. So as you can see, it is not working out, so we are simply going to ignore this iteration and move forward. So now we are going to check that if the element that is present in index 0 had higher priority than the element present at index 1. As you can see, 0 we had index at index 0 we had 1 present, so we are simply going to write 1 here, and at 1 we have 0. So as you can see, this scenario is true. Actually, it is actually working out really well. So in this case, simply allocate one more candies to this element than the one this had. So as you know that 0 had one candy, so we are simply going to allocate two candies to this one, just one greater than this. And this way our array should be updated something like this. And this is our final answer that we are getting. This is our final answer, and simply we will total the sum of the elements that are in this array. In this case it is 5, and that is what we are going to return. So what we are doing in this case, simply to solve the problem, is that the array that had been given to us, we have to, at any particular index, we have to consider the left and the right one and adjacent elements that are present to this one. Okay, the logic is that we will start from left and we will move till right. And then that's what we are doing. If the right element had higher priority than the left one, simply assign one more candies to this one. That is what we are doing in this case, simply assigning one more candies to this one. Okay, after doing this iteration, we have arranged our array in this order. Then we will do a iteration from right to left. Okay, again we are doing the same principle here, that if the element present at left had higher priority than the element present at right, simply assign one more candy to this one more candy to this one. And after doing this iteration, what we will have is that if the element that is present in between had higher priority than the element present at the left side of it, then our given element will have more candies. And if this element, that is 0, is having lesser priority than the element present at right, then 2 will have more candies. That is the logic that we are applying for solving this problem, and this is what they are asking. So now let's just see how we have done this. So as we have already declared the size of the vector, then we are simply here moving from left to right and checking the values. Then here we are moving from right to left, again checking the value, and simply then we are calculating and adding the values of the element that are present in answer, and simply returning that as an answer. So as guys you can see, it is working perfectly fine. With that, today we have solved both GFG and Leetcode POTD. We hope that you guys be able to understand it. With that, over to you, Shivam.
Okay, so yeah, guys, thanks for joining with us. We will catch you up tomorrow.